Hello Zimbabwe, hello South Africa, hello India, hello everyone around the world. So we have an interesting job here. This is a small amplifier. This is coming from an electronic repair shop. And what did they saying? Yeah, the amp, they received this amp as no sound. The amp was turning on but no sound. They replaced TDA 2004. You can see this sound chip. Maybe you can see. They replaced this chip with another chip, but it's still no sound. So, yeah, the technician bring it like this. He said the amp was coming on with no sound. I thought maybe sound IC. I replaced the sound IC. Still, even with a new sound IC, we don't have sound. Okay, this is some kind of cheap small amplifier with the 2-input power source, the one for AC and DC 12 volts. We have a linear power supply here. You can see this big transformer which is coming here. Yeah, we are trying to read out the schematics before we start working on this. We have to know what's going on here. We do have this linear transformer which is stepping down some voltage and is coming here. Here we have the rectifier. After the rectifier, we have some filters, capacitors in parallel mode. And here, the 7805, that's a 5 volts regulator. Here we have that sound IC. Okay. Here we have the speakers output, and we have music input, and the digital display things here. Nothing special about this small thing. So what we can do first, let's put this on power. Let's connect this to the power source and see if it's turning on. That's what we have to check first. If this thing is still coming on with no sound. So as you can see, we have the blue light here. Off. On. It is turning on. You can see the blue light. Let's put the USB flash here. And let's see, here we do have a speaker. Let's see if we have any sound here. Volume is at maximum. You must have a clear sound. There's no sound coming out. Okay. So if the sound IC was changed and you still have no sound, what we can check here? Let's look for a USB flash with the light, because we need to see if this panel is receiving 5 volts. That's very important. So I do have this USB with a light, and you see this USB must have light, red light, and there's no light. So we just find the problem in less than 5 minutes. So the reason why this amp is not turning on is not because the sound chip is faulty, but it is because we do have a USB port here. We have plus and minus and some data pins. We don't have 5 volts there. So if we try to find out why we don't have 5 volts, we'll go back to linear regulator 7805 to see what voltage do we have on that linear regulator. This is very simple. We do have the regulator here. I'll stick one probe here on the ground and I'll check the first pin 2.4. The middle pin I believe is ground and the output is 0.98. So on the regulator we don't have a voltage there. Let me do a trick. Let's supply the input voltage on the pin number 1 of the regulator. I'm just curious to see if we can see something. To see if this regulator is outputting anything. I'm supplying on pin number 1 and still we don't have light. What about on the output pin number 3? Nothing. So we can conclude that either the regulator's fault or something else is not right here. So how we can fix something like this? Let me look for this regulator and then we'll try to find out how best we can solve this problem. Let's see now. So what did I found? I found this regulator 7805. So let's try to modify this, because the sound I see is good, but the 5 volts is not receiving power. So let's try to use this linear regulator. So let's check some voltages. What do you have on this transformer? 15 volts. Okay. volts on the rectifier. We do have 14 volts. Here seems someone who wants to replace the resistor. Here, maybe you can see, we have a resistor at the back of the panel. All the components, they are meant to be on the other side, but we have a resistor here. 15 volts. On the other side, 2.4 2.41, 2.4 volts. Okay, where's that? Here we have 7805 here. I'll check on the pin number 1, 2.4 volts. You can see on the screen. So I believe here's the problem, because on the input of the linear of 7805 regulator, we must have around more than 10 volts. But in this case, we have something like 2.4 volts. 2.4 volts on the input of the regulator cannot output 5 volts, logical speaking. So what do you think we should do here? I think you just save the regulator. I don't think the regulator is fault. I don't think so. Diode mode. Let's check this regulator. And the regulator is okay. So I think something is wrong with this resistor. Why do we have 14 volts on the other side? We have 2.4 volts. What do you think? What about using what do you call that one? I don't need this resistor here. I'll take out the resistor and I'll come with a fuse. I'll come with our own fuse here. Because I believe here's the problem. Because from this resistor, our regulator is getting power. So if the input of the regulator is receiving 2.4 volts, there is no way we can get 5 volts output. We'll see. We'll see, but I don't think the regulator is faulty. I don't think so. I'll measure the resistance of this ohms. Let's measure the resistance of this resistor. Where's that resistor? This one. Like 45 kilo ohms. The resistance probably is very high. Probably someone who tried to fix this put a very high value resistor. Maybe what I think happened, the person who tried to fix this, he seen a blown up resistor and he replaced it with the wrong value of the resistor, and at that moment there was a voltage drop. So let's see now. And now we have light. You can see this green light. Maybe you can see. And it's flashing. Let's test. Let's test. Let's test to see. I'm curious to see if we are going to have sound here. Let's power off. I'm connecting the speaker. Just like this. Now, let's power on. You see, it's working. So we just corrected the mistake that has been done by another technician who tried to fix this. So actually they replaced the sound IC for nothing. Maybe the sound IC was faulty, but what we've done here, I concentrate on the USB port because from this point I know there must be 5 volts for the USB, and I checked the voltage was like 0.89 volts, and I go back to the regulator. The regulator was not outputting anything. I check on the input, there was like 2.4 volts, of which we must have something above 10 volts. And I check, there was a resistor which was replaced, and this resistor was the cause. Where's that resistor? I can't see it anymore. But what's the cause? Probably he's seen a blown up resistor and replaced with a wrong value resistor. You are supposed to replace like a very low ohms resistor, maybe less than 10 ohms resistor. So we took out the resistor and we put our calibrated wire, and we have a working amp. Again, let's test one more time. You can hear the sound. And it's playing. You can hear the sound. It's working fine. So what I will do, I'll stop this video now. Like, subscribe, don't forget to turn on the notification bell. Yeah, that's what I always emphasize about electronics. You have to learn the basics. You have to know how things works, how a resistor is working, how a capacitor, how the rectifier is working. This was just a simple silly mistake by another technician of replacing a very low ohms resistor with a very high value resistor of about 45 kilo ohms resistor. And that resistor, what that resistor is doing, there was high resistance of voltage to the extent that on the output of the resistor there was like more than 8 volts voltage drop. It was from 14 volts to 2 volts, close to 10 volts voltage drop. Now the amp is working fine. So I'll put all together. Like, subscribe, don't forget to turn on the notification bell for future updates, and see you on the next game. Bye.